welcome to Maths with Bob. Today we're actually going to look at some of the formulas involved in differentiation. The first one is the power rule, which after using the first principles, after a lot of experimentation, they actually developed quite a few rules. The power rule, chain rule, quotient rule, function of a function rule. Well, the first one we're going to look at is called the power rule, which just says if I have x, the variable x, to a real number n, and if I want to differentiate it, basically all I need to do is grab that number n and pull it down the front and decrease the original power by 1. So a quick example, say, let's do a few examples. So if I want to go d dx, say of x to the 100. Well, it's going to just be 100 x to the 100 minus 1, which would be 99. Okay, say I had d dx, okay, x to the half. This would be, what, a half x to the a half minus 1, negative a half. Okay, suppose I had d dx, let's say x to the minus 5. Okay, the answer would be what? Minus 5 x to the, now minus 5 minus 1, minus 6. Okay, well let's have a look at a few other sorts of ones. Suppose I had d dx, say of x to the power pi. Well, yeah, pi is a number. Pi, okay, x, drop the power by 1, minus 1. How about d dx over x to the power e? Well, e is a number, okay, e, x, e to the minus 1. Okay, let's have a look at some constants, okay. If I had a constant, I could rewrite a constant as, say I had 7, d dx. I'll write 7 as x to the power 0, okay. Basically because x to the power 0 is 1, 7 is just 7 times 1, and you can show that the derivatives of constants is 0 just by using this little rule again. I'll get what? 7 times 0, okay, it'll be x to the 0 minus 1, okay, but it'll actually end up giving me 0 anyway, because basically 0 times anything is 0. Okay, all right. Well, the next rule we're going to look at is the chain rule, which is sometimes called the function of a function rule. The easiest way to do these ones is you have a function raised to a power. So what I always do is I grab something and let's see if I can cover it up. Here's a little dragon. I'm going to cover up my function. So I'm going to actually cover up the function and I'm going to differentiate around the function to start with. So I go, okay, n function x to the n minus 1. So I've actually pulled the power down, reduced the power by 1. Okay, now I've got to differentiate, but by what I've covered up, I guess you could say. And what's underneath the dragon? Well, what's underneath the dragon is in fact the derivative of the original function. Okay, so we have to multiply by f dash x. Okay, so let's actually apply this to a particular problem. Okay, let's actually try, say something like, say y is equal to, the square root of 6x cubed plus 7. Okay, so what will we do here? Well, first of all, we'd write it as, y is equal to 6x cubed plus 7 to the power of half. Okay, now where was that dragon? Okay, let's grab the dragon. Here. Okay, now we're going to cover up this particular function here. Okay, so we differentiate around that. Okay, so it becomes, so let's actually write that over here. Okay, so y dash, or the derivative of the function, y, or dy dx, another notation for it, y dash, is, a half. Now, what's underneath there? Okay, oops, this is what's underneath there. I'll grab the actual function itself now. But it's, a half of 6x cubed plus 7. Now, notice this hasn't been affected. Now, the power has, because we're differentiating around this function, so it's a half minus 1, so it's minus a half. Now I have to multiply it by this thing here. Okay, I'll just have a look at this. Okay, that bit there, the f dash x. So we have to multiply it by the derivative of what was under the dragon. Now, what's under the dragon? If I can, let's have a quick look. Can I actually move the dragon? Okay, I'll move the dragon away. Okay, so what was under the dragon? Well, it was actually the function 6x cubed plus 7. So its derivative is as you know, to bring down the power, becomes 3 sixes are 18x to the power 2. So it's just going to be 18x squared. Now, because the derivative of the 7 is actually 0. Okay, so we can simplify this. You can see here we could cancel. Let's cancel a few things. Okay, 2, 9. Okay, so we end up getting what? The derivative of y dash is equal to what? Just 9x squared, then 6x cubed plus 7 to the power negative a half. Now I could put that underneath the 9x squared and write it as 9x squared all over the square root of 6x cubed plus 7 using that negative a half. Okay, but we'll just leave it like that for the time being. So this is the derivative now of the function using what's called the chain rule. Okay, let's have a look at the next rule. Okay, the product rule. Now, the product rule, as you can see here, is in fact basically the derivative of two functions multiplied together. Now, it's not as simple as just getting the first function, differentiating it, and multiplying by the differentiation of the second function. Okay, it's more complicated than that, and you can see here the rule basically says the derivative of a product is the first one by the derivative of the second one plus the second one by the derivative of the first one. Okay, so let's actually just make up a function. Okay, so let's make up a function. Y is equal to, say, here we are, 5x to the power 4. And actually just use the one we did before, 6x cubed plus 7. Okay, now the first thing to recognize is that this is a product. Okay, the first thing is, let's have a quick look. There is this function at the front. We call this one u. Okay. And this other function here, we'll call that one v, right? Okay, so what some people actually do is they put a circle around this one, and a circle around that one, and say that's u and that's v, and then they go down to the side and say, well, u is equal to 5x to the power 4, therefore u dash, which is the derivative of u, is pretty easy. 5, the 4 comes down, 5 4s are 20, x decrease the power by 1, 3. That's not too bad. And we know v is equal to, okay, 6x cubed plus 7 to the power of half. And we differentiated that one before. The half comes down. Let's go through it again. Okay, v dash is equal to, okay, a half, 6x cubed plus 7 to the negative a half, multiplied by the derivative of what's inside, which is 3 sixes are 18x squared. And the derivative of 7 is 0, as you know. Okay, so that would then simplify to, as we had before, so v dash would simplify to what, 9x squared, and then 6x squared, or cubed, I should say, plus 7 to the negative a half, right? Okay, so we're now going to apply the product rule. Okay, so let's actually go through and apply the product rule. So, okay, so let's have a look. So, y dash, okay, so y dash is equal to the first one, okay, 5x to the power 4, by the derivative of the second one, which is, we've got down there, times 9x squared, 6x cubed plus 7 to the negative a half. Okay, then it's plus the, okay, we're going to need a bit of room here, so let's see if we can move this. Okay, let's move that over there. Okay, so we're going to now need to add on. Okay. So the second one, which is the v, okay, the 6x cubed plus 7 to the power of a half. Okay, that's just the function as it is, multiplied by the derivative of the first one, which was, you can see here, the derivative of 5x to the power 4 is 20x to the power 3. Okay, so we have a sort of a bit of a messy expression here, which we can actually factor quite amazingly. So I'm just going to show you how to factor this. So I always say, if you have negative indexes, always take out the negative indexes. So what would we have? We'd have, let's try and simplify this. We'd have 5 nines are 45. So let's have a look. This would be equal to what? 45x to the power 6, 6x cubed plus 7 to the negative a half, and then that'd just be a 20x cubed and 6x cubed plus 7 to the half. Now, always you can see here we can take an x cubed out. we've got 45 and 20, so we could take a 5. So let's first of all take out 5x cubed. Now, we can also take out this negative index. So 6x cubed plus 7 to the negative 1/2. Now, what is left? Well, let's have a look. If I take, obviously, out of the first term, I've taken the 6x cubed plus 7 to the negative 1/2 out. I take out a 5x cubed out of a 45x to the 6th, then we should just get 9x cubed left. So if you multiply 9x cubed by 5x cubed times 6x cubed plus 7 to the negative 1/2, we should get that first term back. You can check that yourself. Okay, so now we're going to take the 5x cubed. This is a tricky little bit. Now, obviously, there'd be just a 4. 5 4s are 20x cubed. Now, how am I going to take out a 6x cubed plus 7 to the negative 1/2 out of 6x cubed plus 7 to the power positive 1/2? Now, this is a bit of a trick, but if you just write that as 6x cubed plus 7 to the power positive 1, just have a look at that now. 6x cubed plus 7 to the negative 1/2 times a 6x cubed plus 7 to the power positive 1. Remember, you add the indexes. So the indexes would add to 1/2. You have negative 1/2 plus 1 is positive 1/2. So now you've actually got in that big square brackets, you've got an expression which you can actually simplify. So let's actually see what it simplifies to. We get 5x cubed, 6x cubed plus 7 to the negative 1/2. That's the factor we took out. Now we've got, what's that? 4 6s are 24 and 9. Okay, we've got 33 lots of x cubed, and a 4 7s are 28. Now sometimes you may even be able to factor that expression there, but at this stage we are just going to leave it like that, and we can't take any more common factors out. Okay, so let's look at the final rule now. Okay, well, this is our last rule, the quotient rule, where we have actually a division of two functions, u and v. U and v are both different functions, and you can see here that the actual derivative of u over v is in fact v u dash minus u v dash all over v squared. We normally remember it by a little phrase that says the bottom by the derivative of the top minus the top by the derivative of the bottom all over the bottom squared. So most people actually remember that little phrase rather than the actual rule itself. So just remember, bottom by derivative of top minus top by derivative of bottom all over bottom squared. Okay, let's actually have a look at a function now. Let's make up one. Okay, say y is equal to, okay, let's have a look. 5x to the power 4 all over, okay, let's do the, okay, what's the square root of 6x cubed plus 7? Okay, well, the first thing, I guess, when you look at a function is to realize what rule you're going to need to use to differentiate it. And here, hopefully, we can see that we've got this 5x4 over the top, okay, of this bottom function down here. Okay, so hopefully we can see that we actually do have a situation where we've got a top and a bottom, or a fraction, if you like, of functions. One function on the top, one function on the bottom. Now, what a lot of people do is they actually then go ahead and circle this one and call it u, and then they circle this one and call it v. Then they go down to the side and say, okay, u is equal to 5x to the power 4. Then u dash, the derivative of u, is 5 4s are 20, x, drop its power, cubed. Then they'd write down v is equal to, we can see here, we've done this one before, 6x cubed plus 7 to the power 1/2, and its derivative, v dash, okay, via the chain rule or function rule, which I'll actually just write down the end result, which is 9x squared, I think 6x cubed plus 7 to the power negative 1/2. Okay. Now then we just apply the rule, and let's go ahead and apply the rule. Okay, let's go through it. Okay, y dash would equal, okay, let's have a look here. Y dash, okay, so it's the bottom function, which in this case is this one. Let's write it as 6x cubed plus 7 to the power 1/2. Okay, I'm running them in index notation. You'll see why later, that we'll be able to extract common factors this way. Okay, now it's by the derivative of the top, that's u dash, okay, which is a fairly simple one, which was what, 20x cubed. Now it's minus, we have to remember it's always minus. Now the top, which was 5x to the power 4 by the derivative of the bottom. Now, the derivative of the bottom is that v dash down the bottom, which was 9x squared, and then it was 6x cubed plus 7 to the negative a half. Okay. All right, so it's still all over the bottom squared. Now, the bottom squared is going to be what? The square root of 6x cubed plus 7, all squared. Now, when that's squared, obviously that'll just drop the function out because we have a square root squared. And we'll end up getting something like this. Let's have a quick look. Let's rewrite that as 20x cubed. Okay, 6x cubed plus 7 to the power. Now, it's a positive a half here. Minus 5 nines are 45. 45x to the power 6. And a 6x cubed plus 7. Now, this is to the power negative a half. And it's all over the bottom squared, which would be just 6x cubed plus 7. Now, we can factorise this further, so this is y dash, and we can take the negative index out again. So let's take out the negative index. Okay, so let's say, okay, y dash. Okay, let's have a look. Well, we can take a 5. Okay, let's take a 5x to the power 3 out. Okay, we'll also take out a 6x cubed plus 7 to the power of negative a half out now. Okay, all right, so we're taking 5x cubed bracket 6x cubed plus 7 to the negative a half out of the first term. Now, obviously 5 fours are 20, so there'd be a 4 here, and this is where we have to remember that if I want to take a negative a half out of a half, it just gives me 6x cubed plus 7 to the power 1. You might remember, okay, if you multiply those indexes together, you can see here you'll get a positive a half, and you'll recreate the first term. Now, we need to subtract off. Okay, now we need to extract the 6x cubed plus 7 to the negative a half out of the second term, which, okay, just leaves the 45x to the power 6. But we need to take out 5x cubed out of that as well. So that just leaves us 9x cubed. Okay, and it's all over this term here, which is going to be what? 6x cubed plus 7. Now, a couple of things here you could do. You could actually bring that back up into the other term, 6x cubed plus 7 to the negative a half, and write that as 6x cubed plus 7 to the power of negative 3 on 2. But I'm just going to leave it on the bottom for the moment, and then I'm just going to simplify the square bracket expression there. Now, when we actually have a look at that, what will that be? Well, that'll be 4 sixes, that'll be 24x cubed plus 4 sevens are 28 minus 9x cubed. Okay, so that would just give us what? About, let's rub that out and recreate that. That should give us about 15x cubed plus 28, I think. So let's actually just rewrite this expression here. The final answer. Okay. Let's have a look at the final answer. Let's put it in a different colour. The final answer turned out to be 15x cubed plus 28. Okay, well, that's the derivative of that quotient using the quotient rule. Some people actually rewrite the quotient rule as a product. I mean, there's nothing stopping you doing that as well. But this is just an application of the quotient rule. D dx of u over v equals, you can see here, v u dash minus u v dash on v squared, which you might remember. We always remember the chant, or if you like, the phrase, the bottom by the derivative of the top minus the top by the derivative of the bottom all over the bottom square. Okay, well, thank you for watching, and remember, numbers are your friends. Bye for now.